For centuries, humanity has looked up at the night sky and dreamed of visiting other worlds. Among all the celestial bodies in our solar system, Mars has stood out as the most intriguing. Often called Earth's twin, this red planet has fascinated scientists, engineers, and visionaries alike. But the question remains, could we ever colonize Mars? To answer this, we need to explore the planet's environment, the technological challenges, and the possibilities for building a sustainable human presence. Mars is the fourth planet from the Sun and the second smallest in our solar system. Despite its size, it shares some similarities with Earth: a 24.6-hour day, polar ice caps, seasons, and geological features that hint at rivers, lakes, and even oceans in the distant past. These similarities make Mars the best candidate for colonization compared to Venus, Mercury, or the gas giants. While Venus has crushing pressure and extreme temperatures, Mars offers a relatively safer, though still hostile environment. Colonizing Mars is no simple task. The planet presents extreme challenges that would make survival difficult. Atmosphere. Mars's atmosphere is 100 times thinner than Earth's and is made up of 95% carbon dioxide. Humans cannot breathe this air, and the lack of pressure would cause our blood to boil without protective suits or habitats. Temperature. Average surface temperatures are around -60 degrees Celsius or -80 degrees Fahrenheit, but they can drop as low as -125 degrees at the poles. Radiation. Without a magnetic field and thick atmosphere, Mars is exposed to dangerous cosmic and solar radiation that can cause severe health risks. Dust storms. Mars is notorious for planet-wide dust storms that can last for weeks or even months, blocking sunlight and damaging equipment. Despite these obstacles, advancements in science and technology are offering potential solutions. Before colonization, we must first master the journey. Current spacecraft would take 6 to 9 months to reach Mars, depending on launch windows. This long duration presents problems like muscle and bone loss due to microgravity, mental strain from isolation and confinement, exposure to radiation in deep space. NASA, SpaceX, and other agencies are developing spacecraft capable of protecting astronauts, testing long-duration life support, and ensuring safe landings on Mars's surface. Once we arrive, where do we live? Early missions will likely rely on inflatable habitats or underground shelters, using Martian regolith as protection against radiation. Future colonies could include 3D-printed homes, using Martian soil and robotics to construct durable shelters. Greenhouses, essential for growing food, recycling water, and producing oxygen. Closed-loop life support systems, recycling air, water, and waste to maintain a sustainable ecosystem. One concept is to create domes or biodomes filled with breathable air and Earth-like vegetation, essentially miniature Earth environments on Mars. Water is critical for survival, and evidence shows Mars has large amounts of frozen water beneath its surface and in polar caps. With the right technology, we could mine this ice, melt it for drinking water, and split it into hydrogen and oxygen for rocket fuel and breathable air. In addition to water, colonists could extract carbon dioxide from the atmosphere for fuel and metals from the soil for construction. These processes fall under in situ resource utilization, making use of what Mars already provides instead of bringing everything from Earth. Energy will be vital. Solar panels could provide electricity, though dust storms pose a threat. Nuclear power is another option. Small nuclear reactors could generate reliable energy regardless of weather. Future colonies may also experiment with geothermal energy if feasible. Living on Mars isn't just about science, it's also about the human spirit. Colonists would face isolation, distance from Earth, and the psychological toll of living in a confined, alien environment. To overcome this, communities would need strong social structures, entertainment, virtual connections with Earth, and mental health support. Colonization is not just a technological problem, but also a deeply human one. Some scientists have proposed terraforming Mars, changing its environment to make it more Earth-like. Ideas include releasing greenhouse gases to thicken the atmosphere, redirecting asteroids to warm the planet, or even building giant orbital mirrors. While fascinating, these ideas remain far beyond our current capabilities and could take centuries, if not millennia. Colonization will likely begin with small, self-sufficient outposts rather than a fully terraformed planet. Private companies like SpaceX, along with government agencies like NASA, ESA, and China's space program, are all racing towards Mars. Elon Musk's vision includes sending the first humans in the 2030s with the ultimate goal of building a city of 1 million people by the end of the century. Whether or not this timeline is realistic, one thing is certain: the dream of Mars colonization is driving innovation at a pace never seen before. So, could we ever colonize Mars? The answer lies at the intersection of human ambition, technological progress, and global cooperation. While the challenges are immense, radiation, thin air, and extreme cold, the determination to expand beyond Earth may one day overcome them. Colonizing Mars would not only secure humanity's future, but also redefine what it means to be human, a species no longer bound to one world, but a civilization among the stars. The red planet may be harsh and distant, but perhaps one day it will be called home.